not talking about fireflies. That was already somebody's comment. So you guys have probably heard of news articles about using your devices at night, the blue light's bad for you. That's kind of what I'm going to be talking about, the current research on that. When it's bad for you, when it's good for you, and kind of the reasoning behind that. It's pretty interesting. So what we're finding out is lighting, just like pizza, affects lots of different aspects of ourselves. Pulse, respiration rate, how tired we are, how awake we feel. And it's just really amazing how, something so abstract that we just think of, oh, we need a certain amount of light, influences us so much. So if we go back to science class, you guys all remember sunlight's just made up of a bunch of wavelengths. Some of it's non-visible, but today we're going to be talking about the visible portion, kind of that violet and blue area over there. And that's kind of where the blue light comes from. It's not always accurate, but so our eyes are really, really complicated parts of our bodies, as we're still finding out. So we have 3 types of cells in our eyes that help us with vision. 2 are our rods and cones, help us with our colors and seeing objects. There's also a 3rd called our ganglion cells, and that was just discovered 15 years ago. So that's why there's all this research going on right now. So this slide shows how sensitive our eyes are to the 3 different types of cells. The orange and green ones are ones we're familiar with, the rods and cones. And then the blue one is that 3rd type of cells that helps us with our biological processes, so like our circadian rhythm, things like that. So basically how it works is when our eyes see that wavelength, our body responds and limits how much melatonin we're producing, so that in turn makes us more awake. So it's really fascinating. So if you look at sunlight, it's got this really wide spectrum, but then our eyes are tuned to only certain wavelengths, and there's some overlap, but it's pretty interesting because it's really focused on some of those wavelengths. You can kind of see that that's kind of that blue light that we were talking about earlier. So if we're looking at artificial lighting now, you kind of see there's lots of peaks and valleys. LEDs look different from fluorescents, and that's kind of what we're getting into now. Because we spend a lot of our time indoors. In some professions, we're not exposed to sunlight as much as we should be. So if we're comparing LEDs to CFLs, you kind of see that highlighted area right there. You can see LEDs produce more of that blue light that kind of can tend to make us more awake or more alert than the fluorescent. And that's kind of the concern in some cases and a good thing in others. So if we were imagining the ideal light source to help us with our biological clock, we would get a big dose of that blue light in the morning, and then as the day progressed, we would get less and less and less to help us fall asleep at night. Or we could just reduce the brightness and get less of it that way. And you guys are probably familiar with different color temperatures of lights, warm white, cool white. So what happens when we switch or shift the spectrum, kind of see the graph on the right shows that as we get to warmer colors, we get less of that blue light, which inhibits the melatonin less, so we get tired. And that's currently how all of the LED options that we have right now, they kind of shift from blue light to red light. And they'll either do that by increasing the brightness of the red LED or blue LED, or the warm white LED or cool white LED. And that's kind of what we're limited to right now with our options in lighting. Currently, if we look at lighting that's going to adjust how much melatonin we produce, it's not going to look any different. We're not going to be sitting under pink lights or red lights in the future. It's going to look just like these, but it's just going to be that part of the spectrum, how much we adjust to that. So it's all the lights already produce that part of the spectrum that concerns us. So when is this most important? Most of us are fine, not to alarm anybody, but people who work 3rd shift, think hospitals, police stations, manufacturing, any of that, that's a big concern actually, because we're not exposed to the sun like we are, and basically all the light they receive is artificial. There's already a standard for the healthcare and elderly, and the elderly are especially sensitive population because as we age, our eyes become a little bit more cloudy, and that blue light doesn't really reach our eyes. So we can have issues with our sleep schedule in that way. Also tend to spend more time indoors. And this graph kind of just shows all the current research and some studies that are occurring. You can see a lot of it's coming from Europe. There's a lot of studies and standards that are going to be published at the end of this year into 2019. So this field is just incredible in how much, it's just very dynamic in what's happening. But in the US, some of you might be familiar with the well building standard. They actually came up with a recommendation for the melanopic lux, which is kind of that blue light, way ahead of most other standards. So I have to give them some credit. It's a little bit too simplified based on our current scientific community census, but they did it first. And then finally, the census for kind of recommendations, what you need are, if you work 9 to 5, go outside in the morning, get your big dose of light. Daylighting principles help. Dimming your devices at night also helps. And if you're on that third shift, you want to look at that melanopic lighting. So finally, there's a lot of apps for your devices that kind of can help adjust the color temperature of your device, kind of restrict that blue light that you're getting. And that's kind of what these graphs are showing. So on the left, it's the device or the app is off, and you're getting a lot of that blue light. And then on the right, you kind of see more red light. So that's kind of the how the app works. So it's an area of interest for me, and if you have any questions, come find me afterwards.